Well, hey, good morning, everybody. This is Carpo. I just woke up. It's about 6 a.m. and I was instantly inspired to start researching electricity and gravity. So I decided to do this video, although I may not be completely composed or my electrons aren't flowing to their full potential yet. I'll do the best I can. When these ideas pop into my head, if I don't cover them right away, they tend to get lost in the mix. And I do write a lot of them down in my journal, but sometimes it's just... I got up this morning and I started thinking about how electricity works, because I'm endlessly fascinated with exactly what is happening between electricity and gravity. And so I want to talk about electricity, electromagnetism, magnetism, and gravity a little bit. So please forgive me if you're scientific minded or if you have a degree in this. I'll probably sound like I'm just nonsense, but I'm trying to cover the points that I've been able to research as best I can. Because here's the one thing I found out. If you're researching something and there's an answer for it, you'll find 1,000 pages with that answer on it. If you're researching something and people are not quite sure about it, science won't just say we don't know. You'll end up sorting through 20 different maybe articles or what ifs. And my question was whether what is the relation of electrons, or rather electricity or energy, electromagnetic radiation, any of these, to gravity. And I'm not that much of a science, I don't understand the deepest science of this, so I'll do my best. An electromagnetic energy is created by we can create that with our motors and whatnot, right? When you have a lot of electricity flowing through the coil, you can create a magnet out of it. Okay, so what is a magnet? A magnet is a polarized item that attracts other similar polarized items or metals. Attracts certain electron bonds, perhaps. I'm not sure exactly how metals work with magnets in the deepest sense, but one of the most perplexing questions to scientists has been, what is gravity? It's still one of the most it's still an unexplainable force. It's explainable to those who want to think that it's explainable, but people are still perplexed as to how the gravity from an entire planet can only be good enough to hold a rock up, but if you drop it, it just drops slowly. It doesn't just suck to the earth as if you would expect heavy gravity to. In other words, the gravity of the entire planet is the same as a thread of string, because you can hold that same rock up. It's a very light, very weak force. Gravity is a weak force. And we have all these planets working together with these gravitational pulls and these creating these magnetic... when I picture the solar system, I've always pictured it as a giant, a giant magnet in the center with a whole bunch of smaller magnets around it. And anybody who's played with magnets knows that once they come within a certain distance of each other, they'll flip each other and mess with each other. And this is where people get these theories for these catastrophes, such as Nibiru, or certain planetary upheavals that are caused by other bodies entering our solar system, or more likely just caused by planetary conjunctions, or the distance from one planet to another, how they line up in that system, I don't know. Light is an interesting thing, photons, little packets of photons. This light can be moved by gravity. Light can be turned. Light can be twisted by magnets. Light can be twisted by gravity. Therefore, gravity to me is, of course, like a giant magnet. And since the Earth is not polarized, at least not like a magnet. They don't, there's no, the polarization is caused by the motion of the Earth itself, the toroidal field, the torus of the Earth. This helps to create the, what do you call it? Or I guess our shield, our shield that protects us from sun's radiation, various harmful rays. So we have all these little factories pumping out gravity, pumping out energy, and they're absorbing energy. So my question that led me to this was, is all energy electromagnetic in nature? And of course the answer is no, because there's mechanical energy as well. For example, you throw a rock into a pond, and those ripples that form across the pond, that's not electromagnetic energy, that's mechanical energy. But that mechanical energy is caused by what? It's caused by gravity. So if gravity is caused by electricity, then ultimately every action is electromagnetic in nature. Everything is electric in nature. Every atom is electrons, okay, loaded with these, however it works on the quantum level. These electrons interact with other electrons, and these are forces of energy that are holding everything together. I don't know what really my point is. I guess I'm asking what other people might think, or if there's anyone out there who has a better explanation as to how this works. Ultimately, all of this energy that's coming from the sun, from the universe, from our Milky Way galaxy, that's perpetuating life upon, let's say, this planet, as the way the sun shines on the planet creates life. Does this mean that ultimately everything is rooted in electromagnetism or electricity? It's a very hard thing for me to grasp because there's so many angles to it, and I don't really know, if it's even useful knowledge, really. But it's just fascinating to me because, I don't know. I'm going to do a different video for this other, because I'm probably almost out of time. Now I should just do this here. Actually, I was doing research the other day on how glass and water work. My question is, how the hell do light shine through these things without us seeing them? And I was just shocked that I'd never really been able to, just never really looked for the answer. And I've never met anybody who was able to answer the question for me. So as I expected, my theory was that atoms are mostly empty space, therefore it's just not interacting. The light's not interacting with it. The visible light isn't. And that's exactly what it was. But if you shine UV light, you can see it. So it's only the visible spectrum that passes through glass, right? Through water. Now what about our bodies? It's the same exact thing. Visible light doesn't pass through our bodies because of the way that the light interacts with us. But other wavelengths do. We only see 1% of the visible spectrum. So many of these rays, certain gamma rays, X-rays, all these things can pass through our body. Some of them not harming us, some of us harming us. Sometimes they interact with things, kind of like neutrons might interact with what germanium atoms, down these little neutrinos, I think is what they're looking for. Anyway, it's fascinating which things interact with what and why. Guess that's it. Take care.